So here we are given a problem relating to a taxi driver alternating between two zones. The fact that it's two is going to be important. So we know that a taxi driver is providing service in two zones in that if a fare is picked up in zone A, it'll stay in zone A with a probability of 0.6, or will transfer to zone B with a probability of 0.4, just implementing the complement rule. And we know that if a fare starts in zone B, it'll go to zone A with a probability of 0.3, and in zone B with a probability of 0.7. And we're trying to find the expected profit here. We know that if the trip stays entirely in zone A, it is 6, and entirely in zone B, it is 8, and that if it involves both zones, it's 12. Okay, so first off, we're going to start by noting, we're going to depict this with a transition probability matrix. We know that we'll let the first row correspond to zone A, and second to B. We know here that in zone A, uh, it will go to zone A with probability 0.6, so we'll put that here, which means that we can put this as 0.4, and similarly, zone B will go to zone A with probability 0.3, so we'll put that here, and it'll stay in zone B with probability of 0.7. And there's a formula I've used in a few previous videos. We're going to have to create a system of equations here. In order to find out the expected profit for a trip, we need to know the expected time that the driver will be in zone A and zone B. And to get the long-term proportion in zone A, we'll denote this as pi A, which will equal down here, the column here. So we'll have equals 0.6 times pi A plus 0.3 times pi B. And then here, to get pi b, we have 0.4 times pi a plus 0.7 times pi b. Because we are only in these two zones, we also know that 1, the total proportion, will equal the sum of them. So 1 equals pi a plus pi b. This last equation implies that 1 minus pi b equals pi a, because we can just move this pi b to the other side. Therefore, we can plug this into one of the equations. We're going to do this one. So 1 minus pi b equals 0.6, and then we substitute this in here. So we'll have 0.6 times 1 minus pi b plus 0.3 times pi b. So now we just have one unknown variable, and this should be pretty easy to solve. We may start out by distributing this 0.6 here. So we will have 1 minus pi b equals 0.6 minus 0.6 times pi b plus 0.3 times pi b. And then we will move this negative pi b to this side, and this 0.6 to this side. So we have all the pi b's on the right side and all the constants on the other side. So we will have, let's see, we will have 0.4, because we are moving the 0.6 here, so it will be 1 minus 0.6 equals 0.4 minus pi b, because minus pi b will be plus pi b here, minus 0.6 times pi b plus 0.3 times pi b. And then 1 minus 0.6 plus 3 equals 7. So we have 0.7 pi b. And this implies that 0.4 equals 0.7 pi b. So this implies that for 4/7 of the time, we are in zone B, and then we can implement the complement rule. So 1 minus 4 over 7 equals 3 over 7 of the time in zone A. So we now have our proportion in zone B and our proportion in zone A over the long run. Now, to get the expected value, we refer to the amount of profit expected for being strictly in zone A, strictly in zone B, or some combination of the both. So we can write our expected value, EX. We'll start off with zone A. So it equals zone A's probability or proportion 3 over 7 times, and then we have to consider the trips where it goes to zone B or if it stays in its zone. So 0.6 is the probability that it stays in its zone, and the expected profit is 6. So we can write down first 3 over 7 times 0.6 times 6, and then we'll have to add the probability in the other zone, 0.4. If we look back here, we can see that it is 12 for a trip in both zones. So we'll have that. So we have, first off, we have 3 over 7 times 0.6 times 6 plus 0.4 over 12. And then we have to consider the 4 over 7 of the time in zone B, which similarly we have 0.3 and 0.3 to go to zone A and 0.7 to stay in its own zone. So we'll first start off 0.7 times 8, because 8 was the expected profit to stay in zone B, and then we have 0.3 times 12. Now this is our expected value. We can write this out as equals 3 over 7, 3.6 plus 4.8. You're just multiplying these values, plus 4 over 7 times 5.6 plus 3.6. Once again, just multiplying these values in here. And that will equal 3 over 7, 3 point, or that will be 8.4 plus 4 over 7 times 9.2. Now we can multiply the 8.4 by 3, the 9.4 by 7, then and keep the denominator the same. So we will have, if we multiply 8.4 by 3, we'll have 25.2 over 7 plus 36.8 over 7, which will equal 62 over 7, which is approximately 8.8 dollars, I believe the unit is. There's no specified, but yeah, 8.8 is the expected profit for trip. So we are done.